Hello, everyone. I'm here to talk to you about Hadoop, PHP, and Symfony. So very quickly, who am I? My name is Michael Cullum. That's my Twitter handle. You're very welcome to tweet at me throughout the talk, constructive feedback or abuse, because I'm unable to defend myself up here for the next hour, half an hour rather. I work at a company called Sam Knows. We do interesting stuff with data analytics and lots of buzzwords like machine learning and big data and that kind of thing. I also work on a project called PHP BB, a foreign software that many of you probably used about 25 years ago. And I'm also one of the FIG secretaries, the Framework Interoperability Group. If you want to chat to me about any of those things, come up and have a chat to me after the end of the talk. Sam knows we're hiring, so if any of you are looking for a job, then come have a chat with me, definitely. But that's not what you're here to listen to me about. You're here to talk about Hadoop. This is the Hadoop logo. It's like a cute little elephant. Who knows what Hadoop is? Just a quick show of hands. OK, most of you. Hadoop is, or Apache Hadoop, is actually a suite of applications. It's not like one single application or process that runs. Lighting effects. It's not one single application. It's actually a whole bunch of different ones in a collection, essentially, just called Hadoop. And the idea of Hadoop is that it's designed to support distributed applications and distributed data. So that means if you've got a huge amount of data or you need to do some very large-scale processing on it, that's what Hadoop is essentially for. Now, I keep using this term big data. I actually really hate this term big data. It feels really buzzwordy and sort of, you know, you've got that kind of startup connotation that kind of goes along with it. Hey, look, we're just starting out. We haven't actually got any clients, but yeah, we're doing big data. I actually did an entire talk on this earlier on this year about how I dislike the term big data. The truth is that most of us actually have probably big data problems, because all it really means is that you kind of want to do a lot of stuff with a big amount of data, and it goes beyond sort of being able to use MySQL. Now, if you've got a website that gets any sort of hits at all, then that's going to generate a huge amount of log data. That's a lot of data. That's big data. And then obviously it scales up logarithmically. Realistically, most of the time, it's not actually have a huge amount of data. Like, nobody in this room, I imagine, has the kind of scale of Google size of data. So yeah, your data requirements are probably quite small, but that doesn't mean you don't have big data problems. Big data problems is just like a series of different problems to solve. So where does Hadoop come from? In 2003, Google produced a paper called the Google File System. Now, bear in mind that 2003 was actually quite a long time ago now, which feels weird when I was going through and doing this. And essentially, it was just a way to distribute data, and whether that's general files or actually sort of the back end for a database, and being able to store that amongst a whole series of commodity servers. I don't know how much you know about Google's methodology, but their idea is basically to buy lots and lots and lots of really cheap servers, and then together they provide enough processing power to power Google. Later on, the next year, they then produced an offshoot paper called MapReduce, Simplified Data Processing on Large Clusters. And essentially, this was a follow-on to say, hey, we've told you this is an academic paper on how we can store huge amounts of data, but how can we actually read it? What can we do with it? So as a result of these two papers, a bunch of people came together and sort of started to build this project called Hadoop, which is open source. It's named after one of the founders. I think his son or daughter had a toy elephant, hence the logo, and it was called Hadoop. Hello. Hence the name. So Hadoop can handle a lot of data. Now, most of us, will be handling maybe a petabyte at most, and that's if, so if you're dealing with quite large requirements. Most of us will be dealing with terabytes. Now, sorting a terabyte of data is, or a petabyte or 10 petabytes of data is generally a good statistic benchmark that is used for a lot of scripting of big data platforms. In 2006, to sort 1.8 terabytes of data, it took about 48 hours, 2 days. 2 days to sort some data. 2007, we could store 1 petabyte in 12 hours. That's 1 year later, and a significant amount more storage. And then we take a year on from that, we've halved it, 6 hours to sort an entire petabyte of data. That's huge. Coming down to sort of 2010, we can do it in 3 hours. And this trend sort of continues up to 2012, when you can suddenly sort 50 petabytes in 23 hours. That's a huge amount of data. So the point that I'm trying to make here is that Hadoop is ridiculously powerful, and every year, with growing hardware and algorithmic improvements, it almost doubles, essentially. In 2014, there was a new project called Spark, which allowed you to sort data 5 times as fast as any previous benchmarks, but with 10 times fewer nodes. And now we've drastically exceeded this. Unfortunately, I don't have a few 1,000 node clusters to run some benchmarks on to tell you exact numbers, and couldn't find any on Google. So Hadoop, as I said, is a series of different scripts and components. It has 4 sort of core components. These are the main sort of parts of Hadoop. You have Hadoop core, which kind of just does stuff. And then you have Hadoop HDFS, Yarn, and MapReduce. Now, I'm not really going to talk much about Yarn or MapReduce. This will be the extent that I say on them. Yarn just manages resource management within a cluster, so it kind of tells different things what to do. And MapReduce is a method of executing large tasks. Essentially, what it will do is take a task, for example, let's say you want to count the number of words, instances of a word in a series of documents. So it splits that into a map and reduce. Map will essentially look in each document and count the number of words in each individual document. Then you have a reduce task, which will actually look at all of the different counts for each individual document, aggregate that together, which is just a sum in this instance, and then return that result to you. So those are the 2 different stages. And it can, all of those map tasks can be executed simultaneously. So you can be analyzing 1,500 documents, but you can do it in parallel, which means you can distribute it, which is the idea of Hadoop. If you want to learn more about that, this is a good book. It's about this thick, so take off a year or something to read it. There are a whole load of other Hadoop tools. I'm not going to talk about a lot of them, but I'm just going to sort of quickly run through a few of them. You've got Hive, which I will talk about, which essentially uses Hadoop as a relational, it allows you to turn it into a relational database management system. Apache BigTop, this is basically a way that you can run a couple of shell commands and it will boot up on your local machine, Docker or Vagrant mini Hadoop cluster for you. It's a really nice way to be able to test any of this stuff if you do want to like go home after the talk and have a little play. Apache BigTop, you can get your own Hadoop cluster up in probably about half an hour. It's quite cool. There's something called Pig, which is essentially a high-level language that allows you to write MapReduce tasks without knowing Java. If you know JavaScript or Python, the syntax is very similar. Most of you, I assume, know PHP. So again, it's not a huge leap to go to that. And then you can suddenly start writing MapReduce tasks really easily. Something called Scoop. Scoop is a great way of being able to interact with other database systems. So, for example, MySQL, MongoDB, whatever you happen to be wanting to extract data from, and you can bring that into your Hadoop cluster. Or you can, if you've got metadata in MySQL, for example, you can then sort of join that back in. Spark. Spark is probably something that, if anyone, has anyone used Hadoop in this room before? Okay. So Spark is probably one of the most common ways that people have interaction with Hadoop. It's basically a really quick way of doing MapReduce tasks, but in a nice syntax. And you don't really have to actually think about how MapReduce is actually doing it under the hood. It's also ridiculously quick. Flume just sort of does data streaming, collection, boring stuff. Something called Uzi, it allows you to MapReduce tasks into a workflow so that it can perform one and then on the basis of that perform another. Deployment of clusters to AWS. HBase. HBase is interesting. HBase is what Facebook use for their Messenger. Facebook Messenger is powered by HBase. It's basically a low latency database, but it's not relational in the slightest. So that's why it can handle a platform like Messenger. Zookeeper is really useful even if you don't really do anything with like large amounts of data. It's really great for high availability management. It can handle things like promotion of servers to different roles if one goes down, for example. And it works on sort of like a trust-based model with all the servers talking to each other. It's really good actually. And then hcatalog basically provides interop between a bunch of these things. So what am I actually going to talk about? HDFS. So the core of Hadoop is about how it actually stores the files on a distributed number of servers. And first of all, we're going to talk about that. Then I'm going to talk a bit about Hive, which is allows you to, I should say, using Hadoop as a relational database management system. Apologies for that. That's a great way of importing files, and in the workflow we're going to talk about, that's what we're going to be using Hive for. Then we have Presto. Presto is a Facebook library that you can actually use to then query the cluster. Presto, which is a library to interact with Presto for PHP, hence the PH. And then finally about how we can actually use this in Symfony. So Hadoop HDFS, how does this work? So you have one single node called a name node. And essentially what happens is this name node stores where all of the different blocks of files are located on the cluster. This machine is beefy. It's also a single point of failure for your entire cluster, essentially. Every single request that you do or query that you do, etc., has to touch your name node. I'll talk a bit about how reading data from that works in a second. But then you have as many, it's chopping off the left-hand side, so that's the name node and data nodes at the bottom. And then you have as many data nodes as you want. Data nodes can scale horizontally. It's designed very much that Hadoop is designed that you can use commodity hardware, you can use cheap hardware, and just have as many of them as you like, and you can expand out that way. So you could have 50 or 60, 80-pound servers if you really wanted to. Or you could obviously scale that up and down depending on your needs. Now, these data nodes, that's just a process. As a name node, it's just a process that runs on the machine. There's nothing stopping you from running other things on these machines. It's very common to run MapReduce workers and that kind of thing on the data nodes, which kind of saves you a bit of harm there. It is possible to create, as of very recently, to have a secondary primary name node. So you have secondary name nodes, which basically the point of which is to make the name node boot up faster when it crashes. Or you have now have an alternative one where you can actually fail over to it. That's really new, but really useful for obvious reasons. So how do I read a file from this? Because the data is located in different places and blah, blah, blah. So as I said, we've got a name node which stores essentially all of the different, it stores a copy of the file system. It's like your inodes, I guess, IO nodes. So first of all, I say, hi, I'd like a copy of file.txt. What you have to bear in mind about HDFS is that it is a file system. It's not, you can't load it or mount it. You have to access it through HDFS. It doesn't have necessarily all of the same commands that you might be able to type in your terminal. But a lot of them do exist, ls, but you can also do things like put or the like. So I say, hi, I want this file. Now, that might be a particular binary file or something that's containing database data. Now, the name node will then respond, and it will say, OK, that file has 2 blocks. It's split up into 2 different files, 2 different blocks. Block number 1 is located on these nodes, and block number 2 is contained on these nodes. So I'm like, OK, great. At least I know where the data is now. So we've got our data nodes, which just and I only need 2 of them because I'm only touching on 2 blocks. Every single block is replicated on multiple different machines. One of the things about Hadoop is it's designed to be very fault tolerant. So you can lose a machine and it's fine. And then it will just send back the content of block 1 when you request that particular block from that particular machine. And the same thing will happen when you're touching on a second data node. And you might be, in one particular request, touching on 50 different data nodes. It's really useful to have all of your nodes quite close together, either in like a virtual rack or actually in the same rack. Sometimes disk network bandwidth can peak. So that's something to be worth considering. So that's HDFS. It's a bit of a whirlwind introduction. There's a lot of things to cover. Hadoop is a big topic. There are like entire conferences dedicated to Hadoop, so I'm trying to go through this a little bit quickly. Then we have Hive. So Hive allows you to use Hadoop file system, but have a relational database management system that sits on top of that. So the main core of it is that it has a metastore, and it basically says, and it can then handle and read this data and turn it into structured data. It structures your file system. But what we're actually going to use it for in our particular use case is we're just going to use it for converting and importing files. So I can very quickly demo this, if my laptop will let me. This is one of our development clusters. So there we go. So here it will just show us some of that, some databases. That's where essentially store. So generally you might have a few. We actually only have one on this particular development cluster that's actually in use, and the others are sort of temporary or the like. But the thing is, what it primarily stores, which I'm failing to see, partitions. Okay, here we go. So essentially, it stores each particular table will then be partitioned into a number of different files. So you can bucket it and you can partition it, same as you can with MySQL or a lot of other database systems. That essentially means that when it looks at a where, it means it only needs to look at a subset of data. This essentially just stores where all of those partitions are actually located, actually on disk, and then links them into the file system. So this is the core of what Hive is actually really about. And you can view it. It uses its metastore as MySQL. Hive is essentially just a tool to kind of work out what's going on, work out where to put the files, and then store that into MySQL. But this is the backing store. This is what we care about. Right. Oh. Okay, cool. So what we're actually using it for is importing files, and importing files is super easy. It's literally a case of you put a CSV onto a server, for example, in this particular instance. In this case, it's something that's in my local home directory for Hadoop import, any file name, CSV file, load it in path. You can see that the Hive SQL syntax is very similar to the kind of thing you might be used to with something like MySQL. But what I want to do is actually, I want to change it into a file format called awk. It just basically means it's a lot faster to query. It's also the much better format for something like Presto to be able to interact with. So I load it in file from the CSV. I then grab that data from the table that I've just created and I put it into another table which is formatted in awk format. And it's really as simple as that. I now have data in Hive, and I can now, essentially, if I wanted to, perform some SQL queries on Hive and get that data out, and it will perform MapReduce tasks. The problem with MapReduce is that it's kind of slow. MapReduce is designed for handling petabytes and petabytes of data really, really well. But especially if you're working with smaller data sets, and speaking of like a few terabytes, it's actually quite slow. So Facebook invented a tool called Presto. Now, Presto is a distributed SQL engine. So what does that actually mean? Essentially, it doesn't actually touch on your databases at all. All it does is do the actual work on top of it. It's almost like MySQL, but it's the actual client and the server kind of side of it. But the actual files are underlying. And then it uses the backing store of whatever it's talking to. Now, what that means is that it can talk to a whole bunch of different existing databases. So I can do a query through to Presto, and it can touch onto MySQL data. It can touch onto Cassandra, Mongo, Postgres, Redis. You can even talk to in-memory store if you want to. Or a REST API. Someone was talking about this on the mailing list recently. They managed to get Presto to actually define what the structure should look like for this particular REST API, and then they could run SQL queries on a REST API. Now, the point of Presto is to actually distribute the processing. So we've got all the data nodes, we've got all of the data stored completely separately, but the part that we actually care about is the actual processing of all of that data. So we have a query. This is me, your PHP application, your application, and we send a query to a coordinator. What the coordinator does is it analyzes that query, and it says, okay, I think I can divide this up into these particular tasks. It also has knowledge of like the metastore that you happen to be using, so whether that's Hive or MySQL or the like. So it knows where all the files are located. And then it talks to a whole bunch of its workers, which again you can scale horizontally if you want. And then in turn, they talk to HDFS or Hive metastore or the like. Each one of those performs a subset of that task. And I'll hopefully show you a very quick live demo of that in a minute. And you can scale out your coordinators for balancing, and again, you can scale out your workers. Your workers, as the name implies, do all of the work. They do all the processing. They do all of the data fetching. And they can be stored on the same nodes as your data nodes if you want, but that will have, obviously, performance impact. And it has a cool UI too. It's really actually quite useful. This is our development cluster, and essentially it will show you queries as they're running. It will show you the status of them. It will give you statistics about it. It will give you details about your cluster, how many workers are active, what it's running, and you can then actually jump into individual queries and view stages, which I'll now show you. Right, this bit I'm going to have to. Stop extending my screen, please. Cool. Right. Okay, cool. Okay, so I'm actually just in the Presto command line here, and oh, that's jumping off the end of my screen. So you're not going to be able to see. One sec. Cool, can you see that? Oh, a bit more. There we go. So I mentioned about being able to talk to multiple different database management systems. Here what I'm doing is this cur HTTP get thing, don't worry about what that is, that's just a table. And that's located within Hive. But then what I'm doing also is I'm doing a join onto MySQL here. So this allows you to take multiple different database management systems and do joins on them. Now, that doesn't sound particularly efficient, and you're right, it's not. But the reason it's useful for is if you want to import metadata from MySQL, for example, into your Hive cluster, this can be a great way to do it on sort of like longer running background processes. So this is just a query that I did earlier. It just grabs a couple of pieces of data. And there you go. It's just to demonstrate the fact that you can query MySQL and Hive at the same time. Now, that didn't really handle much data. It did it very, very quickly. It says 0 seconds. That just means under a second. But if I do something a little bit more intensive, I am going to grab the maximum. So this is one of our pieces of data that we have at Sam Knows. Just going to grab the max from there. Now, that just handled 1.31 billion rows and 2.57 gigabytes of data in 4 seconds to form an aggregate and get the maximum on that. That's quite a lot of data. If I did that in MySQL, that would take significantly longer. If I do an average, it will take probably a bit longer, and it will probably use a little bit more data. When you look at an average, you have to actually look at, 4 seconds also. Oh, there's, okay, yeah, that's the same. Okay, it's just being inefficient, apparently. Now, what I can also do is I can then hop into this UI that I mentioned, which is quite cool. So I can see those queries which I've just executed here. You can sort of filter down to a certain subset of queries. Now, when I open my connection, I opened it with a source, and I just put it as SymfonyLive London. Slightly because I don't know who else is using this development cluster at the moment. So here you go. You can see the queries. You can see how they were running. If I do one of those queries, actually, you can probably see it live. No, it executed too quickly. Sorry about that. So I can jump into any one of these queries, and I can kind of see what's going on. He says. OK. So here we can kind of see the kind of data that it's looking at. So it took in 2.57 gigabytes of data. We can see the CPU time, 2.19 minutes, 1.29 minutes. But because it parallelizes across all of your workers, hence it executes in 4 seconds. This is, as it said on the previous page, this is worker, five workers running, each of which have about 12 threads. We can see the query here, which is really useful if you've got like a script that is automatically generating your queries for you. And then here, you can see the individual tasks. So I said it breaks it up into individual tasks and puts them onto different workers. So you can actually see the different workers and what the work that they were producing there. So different IP addresses, different servers, and then they completed their various different like subsets of that. So Presto, how can you do this in PHP? So the way that you actually interact with Presto is through a REST API. You send your queries via a REST API. You get server status via a REST API, which means that, of course, you can kind of do it from anything. They also have a JDBC driver, but essentially all that actually does is then under the hood, then just does a REST connection. So we at Sam knows we wanted to use Presto for doing this, for our data stuff, for our metric data. So we invented this library. This is the logo of Presto. It's a smiley, happy database thing, happier than me. And it's really simple. You can just open up an HTTP client with a variety of different arguments. So here we're saying what the host is. We're saying want to connect to coordinator.hostname.com. That's obviously made up a port and a protocol. As I said, it's a REST API, so it goes over HTTP or HTTPS. If you want to set up HTTPS, it can be a bit of a pain in the arse, but they've improved that over recent times. But the way that we actually set it up was an Nginx proxy that would then go through internally. So we then create a connection, and this is essentially creating a database connection, and then we can just execute a query. And it's as simple as that. We can then get the result. This is just like a result object, which you can then handle as you would very similarly to a PDO object. This does a lot more, because it's very much designed to be about, OK, I know I'm using Presto. I want to be able to interact with it. So you can also get things like all the nodes that are up. You can get the status of the cluster. You can get the query status, server info, the server version, or whatever. And that's a library called Sam knows Presto. So finally, I'm going to talk about how you can use this in Symfony. And it's really easy. Ultimately, you could probably use it that way that I just discussed through that library. And just doing it in plain PHP, but it doesn't really feel like a database system there. You're kind of creating an HTTP connection, and you're specifying a bunch of arguments, and that just seem a bit weird, like you're throwing in loggers and stuff. So what we did is we created a Doctrine Database abstraction layer. Now, this is actually in the same repository. It's just a different directory. So being able to interact with it exactly the same way as you would with MySQL or anything else, it's exactly the same. The only difference is that you have a few different parameters that you pass in. You have things like the schema, which is actually basically the name for a database, because essentially, Presto doesn't know about databases. It's not a database engine, it's a SQL engine. So all it cares about is a schema for when it's actually like reading a query and translating that into what's on the file system. So hence they're referred to as schemas. So schema is kind of what you would think of as your database name. Catalogs, that's Hive, MySQL, whatever. That's basically the host it's connecting to under the hood. And then just other things like your username, password. You can run a query, fetch all, and fetch individual rows if you want. We're currently working on some memory improvements at the moment, doing this in so this is a userland library, which means that it's a bit difficult in terms of being able to manage memory, particularly if you're grabbing like sort of 10 gig of data or more without using sort of a lot of space. We're currently working on streaming and memory improvements there. So to include it in Symfony, it's as simple as this. You can just specify your connection, Presto, specify the driver class, the host name, username, password, char set. I wouldn't recommend a char set other than UTF-8. I'm not sure what it'll do, probably ignore you. The other options, the source, so the actual like local host name, but you can put whatever you like in there. Catalog, so again, that's kind of essentially the host name that Presto connects to under the hood. Schema and a protocol. Now obviously, you'd be wanting to use parameters for a lot of these, so you just like use the percentage sign syntax. But it's as simple as that. And then from anywhere in your Symfony application where you would normally do a MySQL connection, you can do it in, you can do it in exactly the same way. So immediately you have access to interact with billions and billions of rows, and it can only take 4 seconds from your Symfony application. I want to do a live demo of this, but I can't because of IP locks and the like. So yeah, that's how you can use it in Symfony. Thank you very much. That's my Twitter handle. I'll be posting my slides up. I'll also post a link to the libraries and stuff that I've mentioned on Twitter as well. Yeah, I hope you have a great rest of the day.